Newton's laws of motion. So Newton's laws of motion is basically the beginning of the physics. হ্যাঁ, ফিজিক্সটা এখান থেকে শুরু হচ্ছে ক্লাস 11 এর যে স্টাডি অফ নিউটন লজ অফ মোশন মিন্স through this chapter I want to introduce about the various types of force. সেখানে বলা হচ্ছে কি in the previous chapter we have studied the kinematics. So under kinematics what we discuss about the displacement, velocity, acceleration, all those things. But whenever I say the particle, ধর বললাম যে এখানে একটা পার্টিকেল ছিল, the particle is being projected from this point with the velocity of u at an angle of alpha, and I know that the particle will travel a projectile path and ultimately it will have some kind of velocity, some kind of acceleration, what is the displacement, all those things are being calculated. প্রত্যেকটা কিন্তু আমরা বের করতে পারতাম using the kinematics equation. Either I apply the equation for the 1D situation or for the 2D situation. কিন্তু আমরা এই তিনটে চারটে ইকুয়েশনকে অ্যাপ্লাই করে আমরা এগুলো বের করতে পারতাম। বাট whenever we calculate this, we don't consider about the force which is acting on this particle. এই পার্টিকেলটা এমনি এমনি মুভ করেনি। So in order to move the particle, I have to apply the force. হ্যাঁ, আমি যখন বলটাকে থ্রো করছি, so in order to move the ball in this direction, if I say the ball is moving with the velocity u, so along that particular direction, a force must be applied. এই দিকে আমাকে একটা ফোর্স অ্যাপ্লাই করতে হবে। So with the hand, I am applying the force in the same direction, so then only the particle will move. But now, from this chapter onward, I will consider the effect of this force. So in this chapter, we will discuss and understand the basic concept and application of Newton's law of motion. So basically, Newton's law of motion is which is creating the cause of motion. Who is responsible for that? The force. So for any types of motion, the particle is moving or there is a kind of displacement. So that means there must be some kind of force. আমি যদি বলতাম there are two bodies, দুটো ছেলে রয়েছে A and B, they are going for a tug of war. So আমি এখানে একটা দড়ি দিয়ে অ্যাপ্লাই করে দিই। Now this rope I am applying the force in this direction. So whenever I say we are applying a force, so let us say F is the force applied by the person A, FB is the force applied by the person B on the string itself. হ্যাঁ, so initially যখন টাগ অফ ওয়ার শুরু হচ্ছে, so force on both the string are same, that means FA আর FB equal. So once I apply more amount of force, যদি বলি যে রেড কালারের লোকটা বেশি ফোর্স অ্যাপ্লাই করেছে, so he will own because that there is a FA is more than FB. যদি এরকম হয়ে গিয়ে থাকে যে FA is greater than FB, that means the force applied by the A is more than the force applied by B. So that means the A will win the match. Okay. Otherwise, B will win the match. That means whenever I have to decide whether there is a displacement of the body or not, that means there is a movement of the body or not, if A and B both are equal, that means there is no displacement. No displacement. Now, whenever one force is more, another compared to the other one, then there is a displacement, and for that situation only the particle will displace. যখনই কোনো রকম একটা মুভমেন্টের গল্প হবে, so that means I have to say that there must be some kind of force is being applied. So force definition key. What is force? Force is defined as a push or pull which tries to change or changes the state of rest or of uniform motion. আমি যখনই একটা বডির উপর ফোর্স অ্যাপ্লাই করছি, whenever I apply a force, I am trying to change the state of the rest or state of uniform motion. So initially বডিটা যদি বলে থাকি রেস্টে ছিল, once I apply a force and if the force is sufficiently large, then only the body will move. এখানে আরেকটা বডি ছিল which is very large. Okay, so initially particle is in rest. I am applying a force in this direction. The force is not sufficiently large to create the disturbance. Okay, so the either I can create a displacement or disturbance of the movement, or may not be created. যদি create করতে পারি, then only there is a displacement. If there is no displacement, that means I am not able to produce that kind of displacement, means the force is not sufficiently high. এখানে বলা হচ্ছে force is either a push or pull. There are two nature of the force, either a push type force or pull type force, which tries to change or changes the state of rest. So initially আমরা করছি কি এই বডিটার উপরে we are applying a pushing type of force. এটা কি pushing type of force, and here I am applying a pull nature of force. By applying both type of force, what is the intention? Intention is to create the displacement or change the position or change the state of rest. And initially the particle is at rest and applying. So whenever the guard is applying the force, so he is applying a pushing type of force. Because with pushing force, he is trying to change the state of rest of the trolley. Initially, the trolley is at state of rest. Whenever I apply a force, and because that force, the trolley is in the state of moving condition. That means the state has been changed by applying the force. So, whenever I apply the force, in the state of rest, the body which was initially at state of rest has been changed. That may be changed, may not be changed, depending on the amount of force that I am applying. If the same body is pulled, initially the earlier one is a pushing type of force. Here I am applying a pulling type of force. So whenever I am applying a pulling nature of force, then also the state of rest has been changed. So which is being changed the state of the block. So initially the block is maybe at rest. So we apply the force to create the change of state. So it may be possible that initially the block may be moving with a constant speed. Let us say this is the block, and this block is moving with a constant speed, v equals to constant. Now if I apply a force in the same direction, then the state of motion can be changed. Initially the block is under uniform motion. Now when I apply a force, then the velocity should be increased. V should be increased. Initially the particle is moving constant speed. Now once I apply the force, either the particle is at rest, it will increase always. Because if the force is applied along the direction of motion, then the velocity will increase. If the force is applied opposite to the direction of movement, then it will decrease. So hence we say the force is being applied in both the situation, and depending on the applied force, I may conclude that whether the body will move on. Force apply করেছি মানেই যে মুভ করবে তা নয় কিন্তু if I apply a force, let us say very large amount of force applied at this point, but the rock is so heavy that the force cannot produce the displacement. So here I am saying that no displacement, but still the force is being applied. Here I am applying a force, a pushing force. Let us say P is the force that is being applied, and that creates the displacement. So displacement is there. Okay. So whenever the force is being applied, the objective of force is to create the displacement, and that may be produced, may not be produced. That means it is trying to change that state. It is trying to change the state. So depending on the nature of the force, there are two broad classification of force. One is called the contact force and one is called the non-contact force. Contact force means the interaction between the object that touches each other. So whenever we hit the ball with a bat, that means it is called the applied force. So ball is in contact with the bat. Ball is in contact with the bat. So if there is a contact, then the force is the contact force. Spring force. So there is a spring. I am applying a force so that the spring is now compressed. So spring force is the contact force. Drag force. Drag force is nothing but the friction force offered by the air. Whenever I consider the friction by air or by any liquid, so then it was the drag force. So friction force, whenever I work, floor is offering a friction force, that is the contact force. So friction coming to the contact between the body and the surface. Normal force, it is another type of contact force. So all those are the contact forces. So whenever I am saying contact forces, contact force one means there must be the contact within the two bodies. So contact within the two bodies. And when there is no contact, then it's called the non-contact force. And like magnetic force, electrostatic force, gravitational force, these are the different non-contact forces. So in universe, different types of forces are existing. Either the force will be contact type or maybe the non-contact type. But under this particular chapter, or starting from this chapter onwards, each and every chapter in physics deals with certain quantities of force. Each and every chapter discusses about different types of forces. So that means whenever the new force will come, whenever the information about any force has to become, so we must understand the force completely. So for that you should know the laws. So these are the very basic laws that are already being taught in the junior classes. Newton's first law, Newton's second law, Newton's third law, there are three different laws. I am just going to explain about the laws, what is being stated. It is stated that the body continues to be in a state of rest or state of uniform motion until an external unbalanced force is being applied. Unbalanced force. So if the body is at rest, then it remains at rest. If the body is moving with constant speed, that means it moves with constant speed until and unless a force is being applied. So that force may be the unbalanced force. Should be the unbalanced force. Unbalanced force means what? If I say the body is at rest, if I apply a force in this direction, if I apply a force in this direction, then only the body will move. Why? Because this is unbalanced. So in order to balance that, there must be another force which is acting opposite to that. Hmm. If only one single force is acting, then it is maybe the unbalanced force. Yeah. Provided there is no other forces which is balancing it. So whenever any unbalanced force is not acting, then the body will be either in a state of rest or in a state of motion. So this is defined as the inertia. Hmm. So it states that body continues to be in a state of rest. It remains at rest, or it may move with constant velocity until and unless we apply any kind of external force. So this statement basically gives an qualitative idea about the force. That means what is force? So whenever I see a object which is at rest, so now my conclusion is that means there is no force is acting on that object. And if I see an object which is moving with constant speed, then you must consider that there is also no forces acting on that object. That means by observing these two kind of motion, what I can conclude that the is a qualitative definition of force. By quality, what I want to say that if I observe there are two different systems, one is at rest or another is moving with constant speed, then I conclude that no force is acting. So that's why it is called the qualitative definition. So first law gives the qualitative idea. So if I justify the first law, so means that if the body is at rest, so there is a coin, let us say this is the coin, is at rest. Okay. Now once I apply a force on this cardboard, so cardboard which was initially at rest, it gives some kind of inertia, that means some kind of velocity. Okay. That means the state of rest. So the rest is the state of the cardboard. Now it is in moving condition. Okay. Once I apply the force, then the cardboard is moved, but there is not sufficient time for that coin to get the state to be changed. Okay. I am applying the force on the cardboard. Because of that, the cardboard gets the state to be changed. But the coin is not getting sufficient amount of time to change the state of rest. So now the coin will go inside the glass. Okay. So coin at rest falls in the cup because the Newton first law. So that means once I apply the force, state has been changed. So I am applying the force on the cardboard itself. So that is basically creating the change of state for the cardboard, not the coin which is placed above the cardboard. The same is the logic for the inertia. So once the man is jumped, so man disturbed the net, but the leaves that are there, which is not being displaced. That means the state of rest. So these leaves are at state of rest. So they are not disturbed at the simultaneous. It will take some amount of time to disturb this situation. Okay. So entirely we appear to be in the state of rest, though I am changing the state of the net. So net which was initially at rest, along with that the leaves are also at rest. But once I disturb the state, so initially the state of net is being disturbed initially. That will affect the state some later time. So initially all the particle or all the system will try to hold the state of rest. Okay, similarly here once I pull the cloth, so cloth is being removed, but what about the jar and the book that are there? So the state of rest of those books and jar is not being changed. Why? Because the time interval between these two interactions is very less. So once I apply the force, the state of rest of the cloth has been changed, but that not keep sufficient amount to change the state of rest or state for the glass jar or the book. But if I apply the force fully, if I apply the force fully, then what happens? Then the state of rest of the glass jar or the container that are there, that will be changed. তো আগেরটার এটার মধ্যে ডিফারেন্সটা এটাই হচ্ছে যে হেয়ার I am taking more amount of time. Whenever I am taking more amount of time to pull the cloth, so then the state of the flower vase or the utensils that are placed over the table, you get time to change the state. I have to apply the force very fast so that there is no change. So this property is called the inertia. This property is called inertia. Inertia is basically the quantity which is associated with the mass, directly proportional to the mass. So body having a lower value of mass having the lower value of inertia. Body having a higher value of mass is having the higher value of inertia. So Newton's first law basically is also known as the law of inertia. So there are two types of inertia that we have already discussed in this particular type of law. One is the law of rest or the inertia of rest and the inertia of motion. So whenever I apply the force, whenever I apply a force, initially the particles are in rest, so it should attain a state which is known as the inertia of rest. The particle which is at rest is inertia of rest. Similarly, the particle is moving with constant speed, so it is under the inertia of motion. Inertia of motion. So with the application of force, what I am going to change, I am going to change the state of inertia. If I apply a force, then the inertia of rest can be changed to inertia of motion. Or inertia of motion can, if I apply a force on this particular second setup, then the inertia of motion can be changed. Okay. So in both the situation, what I am trying to achieve, I am trying to change the state of inertia. Okay. So that's why it's called the law of inertia. That's why it's called the law of inertia. So first law is nothing but the law of inertia. Now moving on to the next type of law, which is called the second law. So before analyzing the second law, I have to consider the one parameter which is known as the momentum. So momentum is written by the p vector. So p vector is the momentum. So momentum is nothing but the mass into velocity vector. So momentum is product of mass into velocity vector. So it is a vector quantity. Product of mass into velocity, that means kg into meter per second. That is the momentum. So momentum has direction. Momentum is a vector quantity. Momentum has direction. If the particle is moving towards right with the velocity v, so momentum is p vector should be equals to m into v. So if it is moving towards right, then p should be plus. If it is moving towards left, p should be negative. So depending on the direction of the velocity, the momentum has to be either positive or negative. Okay, so this is represented by vector quantity. So direction is always along the direction of the velocity. So it is the direction is always along the direction in which the particle is moving. So SI unit is kg into meter per second, product of mass and velocity, and magnitude is basically m into v. Magnitude first m into v. Now, what is the significance of momentum? So we understand that momentum is nothing but a measurement of mass into velocity. Now, if I drop two types of particle, one heavier particle, another lighter particle, two bodies, one light, another heavy, on the top of a tower simultaneously, obviously it is easier to catch the lighter one. Why? Because lighter one has a low value of inertia, momentum. What is momentum? So momentum is small m into v. But for the heavier particle, momentum is higher. That should be equals to capital M into v. Okay. Both the particles attain the same velocity. Once I drop the particle, which is of small mass m, another mass capital M, once both will fall by a distance of h, both are attaining the same velocity. So depending on the mass, heavier the mass means more is the momentum. So more is the momentum means it is quite difficult to catch that particular particle, right? Because that impart more amount of force. So higher the momentum means higher is the force. Okay, higher is the force. So now we go inside the Newton's second law. What second law tells that? So take a second law tells that the rate of change of momentum is the applied force. So Newton's second law is proportional to force is basically what Newton said, that force is proportional to rate of change of momentum, that is dPd. Okay, that is the second law. Rate of change of momentum means dPdt. Okay, so that is the applied force. So if the momentum is m into v, so can I say dPdt should be equals to ddt of mv? No. So ddt of mv means product of mass into velocity. Okay, so if I assume that mass is constant, if I assume m is constant, for m to be constant. So dp/dt is nothing but m into dv/dt. Now what is dv/dt? dv/dt is acceleration, m into acceleration. Okay. So P, which is equals to mv, rate of change of momentum is basically mass into acceleration. So finally what you can write, if I apply a force on this particle of a magnitude, and that will create the change in momentum. What is the change in momentum or rate of change of momentum? That is dp/dt, or according to Newton's law, what I can say, F is some constant k into dp/dt. Now dp/dt can be written as equals to m into a. So k m into a, that is the expression of the force. Okay. Now if I apply a force of 1 Newton on a particle of mass 1 kg, then we observe that the acceleration produced by of this particle is 1 meter per second. 1 meter per second square is the acceleration. So if I apply a force of 1 Newton on a mass of 1 kg particle, acceleration is 1 meter per second square. That means what you can say, 1 equals to k into 1 into 1. That means k is equals to 1. As the proportional constant is equals to 1. So starting from this equation, F is proportional to dp/dt, the modified form of the Newton's second law can be written as F equals to mass into acceleration. So acting vector, F is also a vector. Okay. So F equals to ma is the modified version of the second law. When we can apply this? Whenever the mass is assumed to be constant. Mass is assumed to be constant. If the mass is not constant, then I cannot apply this. Mass is not constant means I cannot apply this. Why? Because in certain situations the mass can also vary. Mass can also vary. Let us say whenever the rocket is being propelled, whenever the rocket is being fired, so initially rocket is being stored with large quantity of fuel. So fuel is there. So once the rocket is being fired, it is moving upward. So gradually the mass is reducing. Okay, mass is reducing. Why? Because the rocket is losing the mass in terms of fuel. So mass is being reduced. So since mass is being reduced, so mass is not a constant quantity, mass is variable quantity. So whenever the mass is being variable, so dp/dt can be written as equals to ddt of mv, and now both are variable. So m into dv/dt one part plus v into dm/dt is another part. Okay, so that will give the applied value of force. So whenever the mass is variable, then I cannot apply the concept of F equals to ma. So F equals to ma, it is only applicable when mass is constant. When mass is constant, then only I can apply it. Otherwise, I cannot. Okay. So this is the Newton's second law of motion. We state that rate of change of momentum is nothing but the applied force. F is proportional to dp/dt. Now, so once I lift the foot and we throw it, we drop this foot, so ultimately the foot is going to hit this. So every time it is applying the same force on the object. Here the force is being same. Force is same. But if I apply the force on the different object, mass of the object is different. So mass of the object is different, then the momentum is also different. Okay. Somebody getting the larger momentum, somebody getting the lower momentum. So larger momentum means it will fly away with high velocity or fly away with low velocity. So in all the different situations, I am applying the same force. But the force is being applied on different body. Once this force is transferred to another body, then I have to check whether the bodies are getting the momentum or not. So how much momentum they are getting? That is coming from the directly from the force. Okay. Similarly, in this situation, when the gun is being fired, so from the gun, the bullet is being removed. So this is the bullet. So bullet is moving in this direction. So momentum is m into v for the bullet. Similarly, so gun is being recoiled in the opposite direction, having some, let us say, capital M into V naught. So capital M is the mass of the gun, V naught is the velocity with which the gun is being moved back. So after firing, the gun is moving with the velocity V naught. So if I say capital M into V naught, that is the momentum of the gun then. Okay. If the gun is quite large, then the momentum is also quite large. Okay. So always the momentum being transferred from one body to the other. One body to the other body. Similarly, whenever the rocket is being fired, So then a large amount of gas is being ejected. Hmm. So whenever the large amount of gas is being ejected, so this gas which is being ejected is having a velocity in this direction. So they are ejecting in this direction. So momentum is being transferred in the downward direction. Similarly, another kind of momentum is coming on the rocket itself. Okay. So the momentum by the fuel gas. So same momentum is being transferred in the rocket itself. Hmm. So because of the momentum transfer, the rocket is getting a force which is upward. So that kind of force is known as the lift, which is basically used to propel the rocket upward because of larger momentum transfer. So now come to the last law, that is the Newton's third law. So Newton's third law gives the information about the action reaction. Action reaction. So whenever I apply a force on a wall, let us say the red colored force is the force applied by this man on the wall. So, okay. So this is applied, this is the action force. Similarly, wall is being offering another type of force which is reaction in nature, that is R. Okay. So both are action reaction pair are of same magnitude. What is the meaning? Meaning is that A should be equals to. Okay. Acts in opposite directions. So if I say A is acting towards right, R should act towards left. So they are acting in the opposite direction. Acts on different body. Why? Because A force is acting on wall. A is acting on wall. And R is acting on our hand. Okay. So they are acting on two different bodies. Action reaction pair act simultaneously. Means whenever the action force comes into the picture, at the same point of time the reaction force is also coming. Okay. Both are of same nature. Both are of same nature. That means they are of same nature. Here the nature is contact. Both are contact. So with that contact force, I am applying a force on the wall. Similarly, wall is offering another contact force on our hand. So both are of same nature. Okay. So if the force are being satisfied by these, then these forces are known as action reaction force. And Newton's third law gives the explanation of this action reaction force. Okay. Newton's third law gives the explanation of this action reaction force. Understood? কোনো ডাউট থাকলে জিজ্ঞেস কর absolutely না কোনো ফর্মুলা নেই ও নিউটন থার্ড কোনো ফর্মুলা নেই so Newton's third law basically gives the idea about the action reaction pair. Okay, now come to the different types of force that we are going to discuss about this chapter. Under this chapter, first force is called the weight. Weight is known as the body force or it is known as the gravitational force. That is the force with which the particle is being pulled by the gravity. If m is the mass of the particle multiplied by g, that gives the amount of force which is acting as a gravitational force. Okay, it is experienced by any massive body due to Earth's gravitational attraction, directed towards the center of the Earth, vertically downward direction. So this force is always acting vertically downward direction. Vertical downward means what? It is directed towards the center of the Earth. If I say this is the m, so it is the center of the Earth is O. So mg force is acting toward the center. Mg is acting toward the center. Okay. If the object is being placed over here, let us say the object is being placed over here. So now the mg is acting towards the center like this. This is the mg force. So whether the particle is placed at any place, so always the force is acting here. If I place the mass, then the mg force is acting towards the center. Always the force is towards the center. Okay, and towards the center is always vertical downward. At any place on the earth, if I draw a line which is the radial direction, so this is the vertical line corresponding to this place. Okay, this is the vertical line. So that means if I draw a vertical line, that means I have to draw the point on the earth surface with the center of the earth connected. If I connect the point on the earth surface to the center, then that line is basically vertical line at that. And correspondingly, if I draw another line over here, that is the tangent. That tangent is nothing but the horizontal line at this location. Okay. So always mg force is acting towards vertical downward direction. Okay. So for this mg is acting downward. For this mg is acting downward. For this downward. For this mg downward. So mg is always acting downward. Hmm. So first of all, what is mg? Mg is the body force or the attractive force or the force due to gravitation, and that is always acting vertically downward. Hmm. Now come to the another type of force, normal force. So normal force is the normal force between the contact. Okay, between the contact of the body and the surface. So if the body is in contact with the surface, so surface is offering a force which is known as the normal force, or simply write N. Normal notation is N. So it is nothing but a force acting on the body. So direction of force is always, it is a pushing nature. It is always a pushing nature. So on the block, if I draw the force on the block, so N is in this direction. So it is trying to push the body. Okay. Similarly, on the inclined plane, N should be in the opposite direction. So it is these two are action reaction pair. One N is acting on the block, another N is acting on the inclined plane. These two are action reaction force. So magnitude is self-adjusting force. It is self-adjusting force, means the value can be varied. Okay. Now so far you don't consider the variable force or normal. So you only consider this normal force is constant in magnitude, it is not changing, but it can change its value first of all, and dependent on the situation. Situation to situation, the magnitude of the normal force can be varied. Direction is always perpendicular to the common surface. That's why name is normal. So normal means perfect. In contact with each other and away from the body, that is pushing in nature. Pushing nature. Let us say for this aim, normal is in this direction. For this aim, normal is in this direction. Now for the spherical body, one important thing is that the point where the body is in contact with the surface. So here the point is, let us say at point A, the contact, and at point B, there is another contact. So there are two contact. So two contact in two contact forces. So at point B, draw a line which is passing to the center of the geometry. Okay, that gives the normal at point B. Similarly, at point A, draw another line, will be passing through the point A, point 2. So every time the normal force for the spherical body should pass to the center of the geometry. This is for the only for the spherical body. Every time the normal force for the spherical body should pass to the center of the geometry. So here if I draw the normal, so normal is in this direction on the surface. That means this force, if I project this, that force should pass to the center of the earth. Okay, because earth is spherical body. Earth is spherical body. So if I say there is a ladder which is resting on the ground and one part is resting on the wall. So for this point A and there are B point, these 2 points are touching. শুনতে পেয়েছি। So there is a ladder which is resting on the wall as well as touching on the ground. So we were asked to calculate that small force at point A and at point B. So at point B, if I draw the surface, so this is the surface. So contact surface perpendicular to this contact surface, this is the direction of normal force at point B. Similarly, at point A, this is the surface of the wall. So corresponding, this is the perpendicular. So this is the NA. So whenever you draw the normal is always perpendicular to the surface. Surface is what? Surface is surface of object may be considered, or surface of the floor on which it is resting, that may be considered. Here we consider the surface of the floor. Similarly, if the rod is overhang, so at point A, there is a point contact of wall, and at point B, there is a surface contact of the surface. So for this surface, the NB is acting upward. But for this point A, since there is no surface of the wall, so now here I have to consider the surface of the object itself. So this is the surface of the object that is in contact with the point A. So corresponding this surface, perpendicular to the NA. Okay. So normal, very careful about the normal direction. Normal is always a pushing type of force, first of all, and it is perpendicular to the contact surface. So whenever I see the surface of the object, then that surface. If I see the surface of the floor or surface of the wall and take that surface. Okay. So depending on any one surface particular to that will be the idea of the normal. So here there is only one single contact. Only one single contact at point A. So here the normal will be NA like this way, such that NA will go to the center of the body. Here there is one contact at point A, another contact at point B. So normal at point A should be in this direction NA. Normal at point B should be NB in this direction. The force should be such that it should always pass to the O point. Okay. So this is only for the spherical body. Here the normal contact force is always passing to the center of the body. If the points in this situation, if I say both A and B are the same elevation, then what you can conclude that NA should be equal to NB. These two forces will be equal. If both A and B are the same, that means from the geometry, if I say this is theta, this is also theta. But if I say this is the point A and this is the point B, both are not at the same elevation. So clearly, if I join, let us say this is alpha, this is angle beta. So alpha is not equals to beta, and not equals to beta. That means now the force NA and NB both will pass to the point O. But now NA is not equals to NB. NA is not equals to NB. So normal force is always passing to the point O, but it is not equals to not equal. Now come to the third force, the tension force. So tension force is the tension inside the string. Yeah, tension inside the string. Now tension inside the string is always away from the body. Yeah, away from the body means it is nothing but a pulling nature. So T is acting as a pulling nature on the body. So for this body M, so T is acting upward. Why upward? Because it should act away from the body. Now can take any value depending upon the question of the strength of the string. I cannot say T is always constant. T may be of different value. Now T is a notation used for the tension force. Tension comes inside the string only. And regarding the string, there are two types of string. Either one string may be ideal string, another is the non-ideal string. What is the ideal string? Ideal string is the string which is have no mass. Mass is 0. If I don't consider any kind of mass of the string, then it is called the ideal string. And if I say mass is not equals to 0, the string has some kind of mass, then it is non-ideal. So for the non-ideal string, the tension will be different at different points. String has some appreciable mass. For the ideal string is massless. So whenever the string is assumed to be massless, the tension at different points should be same. Okay. If I say this is the body, we started with a ideal string. So if the string is ideal, so if I say this is the point 1, this is the point 2, this is the point 3, so tension at point 1 should be equal to tension at point 2 should be equal to tension at point where when the string is ideal. If it is not ideal, then the tension will be different. Now string is said to be inextensible, as the length does not change. Whenever I am saying the tension is same at point 1, 2, 3, at all point tension is same, that means string is behaving as inextensible. That means you cannot stretch the string. It is not stretchable. So inextensible string means these are basically the ideal strings. So ideal strings are inextensible and massless. So whenever I am saying a string is massless or inextensible, these two are important characteristics of a ideal string. And if this is not valid, that means the string is non-ideal. For non-ideal string, the tension will differ. So in this situation, what I can conclude that TA equals to TB equals to TC if the string is ideal. If this is not ideal, then the tension will be different at different point. Different and different. Now draw the tension force. So at point A, tension is always acting away from the body itself. So at point A, tension will be acting upward. So the tension T at point A. And at point C, from point C, it should be acting away. So here it should be TC downward. Okay. So the point where you are willing to find the tension, not a point away from that. So TC is away from TC means downward. So now what I am saying that TA and TC both are equal. TA and TC both are equal if I consider the string to be an ideal one. So in this situation, TA is equals to TC if the string is ideal. If it is non-ideal, then the tension is different. Now here there are two strings. So on the body there are two strings. Let us say this is the one string where the tension is acting in this direction T1. There is another string where the tension is acting in this direction T2. Okay. Depending on the angle given, so I can draw this angle at an angle alpha. Let us say it is at beta. Okay. So T1, T2 are at an angle of alpha and beta with the vertical corresponding to tension. So depending on the number of string, if the number of string is 2, then the tension will be 2. So number of tension is nothing but the number of string. How many number of strings are there? Depending on that, number of strings will come into the picture. So here draw the tension in the force. So here the string tension will be in this direction, here from the body. Here one tension will be in this direction, T1. Another tension is in this direction. So always tension is acting away from the body itself first of all. And in this situation, there is one contact force over here. So another normal force will be there. Now there is one body force acting vertically downward. So these are the different forces acting on this body. Similarly, in the second situation, no contact force, only mg is there. Why? Because this m is not in contact with any kind of surface. So here the body is in contact, so n is there, so contact force will be there. Contact force is there. So by this method, I can identify what are the different forces acting on the body itself. Now, so if M1 and M2 are connected by two different strings, so for M2, so let us say this is the string tension T2. For M1, there is string tension T1. That means there are two tension. Why? Because there are two strings. So if I try to draw the force on M2, so for that there is another force M2G is acting downward. For M1G is acting downward. And since this string is an ideal string, so from this point, there is another tension T2 is acting downward. Okay. Why? Tension should always be the same if the string is ideal one. So these are the different forces acting on M1. These are the different forces acting on M2. So whenever I mark the forces, that means now I can able to see what are the different forces acting on this body. So whenever I see those forces acting on this body, now my next task is to draw the free body diagram. So what is free body diagram? So free body diagram is nothing but the pictorial representation of all the forces that is acting on the body itself. Okay. So once I identify the different forces that are acting on the body itself, now I have to mark with arrow. Once I mark with arrow, হ্যাঁ বডিটাকে ফ্রি তো করতে হবে, বডিটা ফ্রি করে করবো ঠিক আছে, কোর্সগুলো দেখাবো না, সেটাই তো বলছি। হ্যাঁ মিনিংটা তুই বলে দিয়েছিস, খুব ভালো কথা। It is a pictorial representation of all the forces acting on the body. So in this situation, let us say this is the M1 body, this is the M2 body. So in order to free the body, what you have to do, you have to remove this contact. So whenever I am removing this contact, that means the normal will come. Whenever I cut the string, then the tension will come. Okay. Once I cut the string and remove the contact, then normal force as well as the tension force comes into the picture. তাহলে আমি দেখবো কি M1 মাসের উপরে there is one tension force is acting, one normal force is acting, one empty force is acting. If the friction is there, then the friction will also come into the picture. Similarly, on the M2, you have to cut the string. So since these are connected with single string, the tension over here should be the tension over there. Both are same. If I say they are connected the same string, and there is one mg force is acting downward. Okay. So like this, you have to identify different forces on the body. So steps: identify the body or system which is to be analyzed. So system is very very important. System is very very important thing. Why? Because system may be defined by us. I am the responsible to define a system. So how many bodies are taken inside the system, that is purely decided by my myself. ঠিক আছে? এবার আমি যখন ডিসাইড করব, ফার্স্ট অফ অল I have to decide a coordinate system. Now represent all the forces acting on the body by vector. Vector means by arrow. Once I draw all the forces by arrow, now I can identify what are the forces and direction of that force. Now try to resolve the forces. Resolve the forces. Under vector chapter, what we learn, the resolution of vector. And also resolution of vector means resolution of forces. So what are the forces that are there? You have to identify the different forces and finally resolve all the forces into components. So draw the free body diagram of the block of mass M. So for this mass, you have to identify the free body diagram. So if I consider this is our system, this is our system. So first of all, you have to say M is only our system. So on this body, mg is acting downward and this bench is offering a normal force in the upward. So these are the two forces simply acting on this block. So this is the free body diagram of the small m. Okay. Similarly, if I say there are three particles, let us say this is one system, one body, bench is the another system, or earth is another system. If I want to calculate depending on the system, so for m, what is the free body? For small m, is the mg is acting downward, n is acting upward. That's all. For the bench, now this normal which is acting on the m is acting as a reaction force. Okay, and entire bench has some mass mg. And these are the two contact points on the surface of the earth. So here there is another normal contact N1, N2. Okay. So this is the entire free body diagram for the bench itself. Now forget about the bench. Now come to the earth. So on earth is N2 and N2 will act as the reaction force. So one N2 is acting in this direction and the N1 is acting in this direction. So these are passing to the center of the earth. So depending on the system chosen, if I take only earth, so you have to show the free body diagram as N1, N2. If I choose to draw the force on the bench itself, then N, Mg, N1, N2 all will come. If I say only block is our system, so only M and Mg will come. So depending on the system chosen, the nature of force or difference of forces will be there. So depending on that, there are two forces which are action reaction force. Every time I'll get the one action reaction force. So mg is what? This mg is the force on small m offered by the earth. Same logic, mg is another force offered by the small m on earth. So these two are the action reaction force. These two are the action reaction force. So whenever the consider you draw the free body, whenever I draw the free body, then this force has to be taken into consideration. Okay, but we don't consider this mg. Why? Because this force is applied by block. This force is applied by block, and I am willing to draw the force on the block itself. That's why that has to be neglected. Similarly, this is the N is the action force on the block itself. Similarly, this N is coming on the bench itself. So this is the reaction force. Okay. So once I draw the free body diagram of the mass itself, then you have to show this N. Once I draw the free body diagram for the bench itself, then you have to show this N, not the other N. Okay. So depending on which force is coming on which surface or which body, that is important. Okay. So N and Mg are not action reaction force. Why? Because N is nothing but the normal contact force and Mg is the gravitational force. So nature of these two forces are not same. Nature of these two forces are not same. And also they are not acting on the same body. Not acting on the different body. Both N and Mg are acting on the same body. So these two forces are not the action reaction force. Okay. These two forces are not. Now let's draw the free body of each block. Let us say I want to draw the free body of M1 block. So for the M1 block, this is the M1G acting downward and normal is acting upward. For the M2 block, For the M2 block, this M1 is coming in the opposite direction. M2G is acting downward, and there is another M2 is acting over here. So M2 is what? M2 is the normal contact force offered by this surface. The M2. Okay. So this is the M2 on the M2 surface. So N1 is the normal contact force offered by this surface. This surface is offering N1. So this is N1 acting on M1. Similarly, there is another N1 acting on M2. So these two are action reaction pair. Okay. These two are action reaction pair. So whenever the action reaction pair will come, if I combine the system, that will taken together, so this action reaction force will always cancel. If I draw the free body of M1, M2 both together, let us say this is the M1, M2 both together. M1, M2. Now N1, N2 will cancel out. N1, N1 cancels out. Only thing is that M1 plus M2G is acting downward, and normal contact force that is acting upward is N2 force. These two forces. Yeah. So whenever I consider the combined system, then the forces that are there, that is normal force, which are action reaction that you cancel out. So what is system? What is system? So either I can take, this is our only one system, because this is S1, this is S2, this is S3. Okay. Or combination of entire thing that can be taken as another system, S4. Or combination of S1 and S3 may be another system. So n number of combination system may be there. It depends on us. System is a body of combination of bodies which are being observed. Okay. Either I can take this man and monkey as a system, or simply man as a system, or monkey and horse as a system, or simply horse as a system, or monkey as a system. So depending on which particles to be considered, depending on the system has to be changed. System has to be changed. So imagine these three things being standing on the surface of Earth. We can assume any one of the body to be our system. Any one. Either I can take monkey or man or horse. So whenever I include, let us say monkey is in our system. Monkey is in our system. So I have the focus on the monkey itself. I am not concerning about what is happening outside. So which is outside the system, that means man and horse, is not a part of the system. I want to draw only the force acting on our system, that means on the monkey. I am not bothered about what is the force acting on man or horse. That is the idea of system. So there may be different types of system. Only system? No, it is not the only one system. Any kind of combination is possible. Any kind of combination is possible. Either include all those things. So here also there are M1 mass is there, M2 mass is there, pulley is there. So if I take everything together, then this is our system. Okay. So if I take everything together, then this is our system, and I want to calculate what is the net force on the system. Net force on the system. So if I say net force, so M2G is acting downward. The one force. M1G is acting downward. Now M1G has no responsibility to move the body. Why? M1G is not supporting the movement of the body. Only M2G is supporting the movement of the body. So net force acting on the system taken together, M1, M2 is M2G. Why? Because whatever the tension that is there on the string, tension on the string, this will cancel out. Okay. So if I consider only M1, M2, string, pulley, all are our included part of the system, then only M2G is the force. If I consider only M1G is our system, if I consider only M1 is system, now the tension is coming to the picture. M1G is vertically downward, normal is vertically upward. So these are the forces acting on the system itself. Okay. So depending on the choice of system, the forces will be different, and accordingly I have to calculate the net force on the system. Why? Because I am going to apply the Newton's second law. That is because F equals to m. What is F? F is the net force on the system itself. And net force. And what is acceleration? Acceleration is also for the system. Okay. So net force equals to F net should be equals to m into a system. Now depending on the choice of the system, the acceleration will vary. But whenever I consider the system, so net force on the system has to be considered. System is in our hand. I have to choose the system. Once I choose the system, depending on the system, if I say only M1 is our system, so only M1 is our system means what is the force acting on the M1 that you have to consider? Net force on M1 only. So the answer is clear, that is just a matter of choice. That is what actually is to be observed becomes our system. We can assume M1 to be our system, or M2 to be our system, or M1, M2, string, pulley, table, earth, all this taken together as a system. So choice of system is going to be very crucial. Depending on the choice of system, you can simplify the problem or you may complicate the problem also. Okay. So taking the system properly is quite important. Now classification of force based on the systems. Now there are two types of force. One is called the internal force and called the external force. Okay. So internal, external are basically dependent on the choice of system. Let us say for the internal force, if the force acting on a body or particle is applied by some other body which is included in the system, then for the internal force. Let us say, if I say this is the entire system. Okay. So now the force on this, let us say F is acting on the string. Similarly, this is another force F2 is acting. So F1, F2 are the what type of force? F1 is internal force. Why it is called internal force? Because these forces are basically within the system. If the force acting on a body or particle is applied by some other body which is included in the system, then called internal system. If it is not included, not a part, then called the external agent. Okay. So depending on that, if there is a tug of war, if I say force, let us say only RAM is taken to your system. Only if I take RAM as a system, so on RAM this force is acting by some external force. Why? Because SAM is not included in the system. If we consider RAM and SHAM and string to be a system, then the pulling force acting on RAM due to SHAM is part of the internal force, because the entire thing is a system. Entire thing is a system. RAM, SHAM, string is a system. So force offered by RAM on SHAM or force offered by SHAM on RAM, these are the internal force. But once we consider only single system of RAM, then the force acting on RAM is applied by SHAM, who is not inside the system. So then that particular force is the external force. Then that particular force is the external force. So for this system, if I say the RAM is our only system, so on this RAM the force acting is by SHAM. Okay. So RAM is only our system and the force experienced by RAM is due to the SHAM, who is external to the system. SHAM is not part of the system. So that means the force acting by given by the SHAM on RAM, this force is nothing but a force is not external. Okay. So there are two classifications, one is the internal and the external. External force means that has been given by some other particle who is not part of our system. Why? Because I have the authority to decide the system. I decide the system to acting as on RAM itself. So RAM is taken to the system, means SHAM is outside the system. So whatever will be the force that is being applied by the SHAM on RAM is basically purely external. And if I consider both are acting as a system, Now RAM, SHAM both are as a part of system. Now whatever the force of interaction between these two particles is there, they are basically the internal force. Okay. So same force once may apply as the internal force and same force may once apply as the external force. It depends on the situation to situation. It depends on the situation. Now let us say I want to calculate the normal reaction on C by B. So first of all, in this type of problem, what you have to understand that if I say entire thing as a system, so entire thing system means the 5 kg plus 3 kg plus 2 kg means 10 kg block is there, 10 kg particle is there, and on this 10 kg particle I am applying a force of 50 Newton. So that particle is acceleration in this direction, that is the system acceleration. So system acceleration is force by mass. The 50 by 10. It is 5. So 5 meter per second square is the system acceleration. Who is the system? System is basically A, B, C. So that means the acceleration of A is equals to B equals to C equals to 5. Now you are asked to calculate the normal reaction on C by B. So on C, if I draw the free body of C only, for the C body, so B is applying a normal reaction on C, and that is this direction. Why? Because the normal is always a pushing nature, is the NB force. No other force is acting on the C body, and because of this normal only, the particle moving in this direction, it is acceleration equals to 5 meter per second square. Now, if I apply the Newton's law, so force equals to mass into acceleration, so MB should be equals to MC into A. Mass of C is given as 5 kg into 5, that is 25 Newton. So 25 Newton is the normal force acting on C by B. Yeah. Similarly, if I want to calculate what is the normal force acting on B by A, for A particle, so if I draw the free body of B, so B has two contact. One is over here and there is over there. So for this side, so this is the normal given by A, and for that surface, the normal is reversed. Why? Because this NB and this at NB are the action reaction force. Okay. So because of these two force, the body is moving in this direction with an acceleration, again system acceleration 5. So net force along acceleration is how much? Na minus Nb. Na minus Nb should be equals to mass into acceleration. Mass of B is how much? 3. 3 into 5 means 15. Now Nb what? 25. So Na becomes 40. Na 40. Okay. So by this method, you have to calculate the normal force on the particle. Why? Because I have initially taken as entire system is the combination of both A, B and C. Why? Because once I take the entire particle A, B, C as system, then it is quite easy to calculate the net acceleration system. Once I get the idea of the net acceleration system, that means all the particle A, B, C, all are moving with same acceleration. All are moving with same acceleration. Now same logic can be applied for the string also. Let us say again I am taking the entire body as a system, entire particle system. So 3 plus 2 plus 5 means 10 kg is being pulled by 20. So for the entire particle is acting as system, means these are the internal forces. So they will cancel out. Okay. So internal forces will never come into the picture if I consider the entire particle or system. Okay, that means they are cancelling out. So net force acting on this system is 20 Newton. So acceleration is how much? 20 by mass. Mass is 10 kg. That means 2 meter per second square. So 2 meter per second square is the system acceleration. Now tension in the A string. So for the A body, tension is always away from the body. So T2 is acting away from the body. So because of the T2, the particle A is moving in the forward direction with an acceleration 2 meter per second square. Okay, so T2 should be equals to mass into acceleration. Mass is 3 into 2 in 6 Newton. Okay, now come to the object B. For the B, one T1 is acting in this direction, away from the body. Another T2 is acting in the opposite direction. Okay, because for B there are two tensions. One is T2 and another is T1. And again, the entire body B is moving with same acceleration A equals 2 meter per second square. So along the acceleration net force is how much? T1 minus T2. So T1 minus T2 should be equal to mass of B 2 into 2 means 4. So T1 becomes 10 Newton. Now you can cross check it by moving to the particle C. So for the C particle, force is 20 Newton is acting over there. And there is another tension T1 is there. Again, the particle is moving with the forward acceleration A equals 2 meter per second square. So net force along acceleration is how much? 20 minus T1. 20 minus T1 equals to mass into acceleration means 5 into 2 means 10. So T1 becomes 10. So that to verify that you are getting the correct answer. Okay. So every time you try to draw the different forces acting on the particle based on the initial system, you define the initial system, based on that calculate what is the acceleration. That is nothing but the acceleration for all the particles that are there inside the system. Okay. Now find the contact force when the system is released from the rest. You release the system from the rest from point A and B. There are two particles or different mass 2 kg and c. Okay. So whenever the particle, let us say, if I say body is resting on an inclined plane of inclination angle alpha, let us say the particle is resting over it. And if the surface is smooth, where the surface is smooth, every time remember that the mg is acting downward. Mg is acting downward. And mg has two components. One is along the plane. That component is mg sin alpha. And that is normal to the plane, that is mg cos alpha. Okay. Now this mg cos alpha force is balanced by this normal force. And this mg sin alpha is unbalanced force. That is, with this force, the m mass is being pulled downward. So that means the acceleration of this particle is nothing but A should be equals to mg sin alpha, that is the force, divided by mass. That means g sin alpha. So whenever I rest a particle on an inclined surface and the surface is frictionless, every time the particle will come down with an acceleration g sin alpha, that is independent of mass. Whether the 2 kg particle is there or the 3 kg particle is there, both are coming down with the same acceleration, that is g sin alpha. Both are coming down with same acceleration g sin alpha. Okay. That means if I say the particles which are coming with the same acceleration, now what happens to the normal contact force? So in this situation, normal contact force will vary. Why? Because both A and B are moving with same speed. So the normal between A and B will be equal to 0. Why? Because both are moving with same speed. If B is moving with higher speed, then there is a contact force. If A is moving with higher speed, then there is no contact force because there is a gap. Okay. So between A and B, whether the contact force is there or not, that depends how fast A and B are moving. How fast A and B are moving. If A and B are moving with the same speed, if A and B are moving with the same speed, that means they are just touching each other. No one is pushing no one. B is not pushing A. If I say B is moving at a faster rate, that means now B is pushing A. That means now the contact force will come. If A is moving faster, that means there is a gap. So since both are resting on an inclined plane and there is a no friction condition, that means both are moving the same acceleration. So in this situation, normal contact force between A and B will be 0. So that will be your answer. Okay. You know contact force between A and B. Now, same situation, if they are tied with the string. If the particles are, instead of touching each other, now they are connected with the string, and again both the system, this particle, this, both are moving same acceleration with g sin alpha. Both are moving with g sin alpha. Okay. So if both are moving with g sin alpha, acceleration is same, that means the internal tension has been 0. There is no tension force. So here also the T will be 0. Okay. Now both tension and normal will only come into the picture whenever the body A and B are moving with two different speeds. And that can only be possible whenever there is a friction. Whenever there is a friction, then only the speed of the body A and B may not be same. There will be different, acceleration will be different. And in that situation only there is a contact force or there is a tension force. Okay. Now find acceleration of the system. Now, whenever this type of pulley block system is there and you are asked to calculate the acceleration, first of all calculate the net force acting on the system. Now, one force is along this mg sin theta. What is that? 20 sin 37. Okay. Now, 20 sin 37, 20 into 3 by 5 means 12. Here, 20 sin 53 means 20 into 4 by 5 means 60. Okay. So for this system, net force acting on this particle is how much? It's 4 K Newton. 4 Newton. This 60 Newton is pulling downward, 12 Newton is pulling downward. So if I say instead of pulley, Can I say both these 2 kg block are being pulled by 16 Newton in this direction and 12 Newton in the direction? Okay. So on this particular system, net force acting on the particle is how much? 4 Newton. So acceleration is how much? 4 divided by 4. Why 4? Because mass is 4. So 1 meter per second. That is your answer. Okay. So understand what is the force, net force acting on the system, and whenever I am saying net force, so only consider the force which is creating the displacement. Here I am not considering the mg cos alpha component. Why? Because here also the mg cos alpha is there. 20 cos of 37. 16 is there. But that 16 is not responsible to create any kind of movement. Here also 20 cos of 53. That means 12 is there. But I am not considering these two forces. Why? Because these two forces are not responsible to create the displacement. So normal is there, N2 is there, N1 is there. I am not considering all those things. Right? Only the force which is responsible to create the displacement or create the movement is the net. So first we understand the system. So on the system, what is the net force? Once I calculate the net force, then only I can conclude what is the net force and correspondingly acceleration. Okay. Now the concept of weighing machine. So weighing machine is a device which is basically used to measure the mass of the body, not the weight. Okay. So if I place a body of mass m on this weighing pan, so mg is acting downward, mg is acting downward. Okay. Now this mg is balanced by the normal reaction. Mg is balanced by the normal reaction. So n is equal to mg. Okay. Now here, once I am standing on this weighing machine, so my foot is touching the weighing machine. So if I say mg is acting downward, so n is acting upward. Okay. Now what is the reading of the weighing machine? Reading of the weighing machine is this indicator. So or that indicator. So that is called the R. So R is what? R is N by G now. What is N? N is the normal contact force coming on the weighing machine divided by G. That is the reading. Okay. If the weighing machine is at rest condition, that means N is equal to mg divided by m. That means m. That gives the true weight. Okay, that gives the true weight. So whenever you are standing on the weighing machine, and if you are at rest, then only it will give the true reading. And if you are moving, then it will give the different reading. So weighing machine measures what? Weighing machine measures the normal. So if this is the system, now I break the system into two different components. One is the only mass and the weighing machine. So for the mass, the free body is mg is acting downward, and normal is on this m is in this direction. Now this normal is coming on the weighing machine. So weighing machine is measuring this normal. Weighing machine is measuring this normal. So once I calculate this normal number, so reading of the weighing machine is normal by g. So that is the answer for the reading. Because every time I have to calculate the normal or reading. So now the reading can be observed either by the true reading or by the difference in reading. Okay. So reading is different. Reading may be either true reading or some other reading. So for other reading, I have to go for the another concept, that is pseudo force. Pseudo force. So pseudo force. আচ্ছা pseudo force আজকে ধরবো না, pseudo force পরে নেবো, আবার দুই থাকবে, হ্যাঁ আবার দুই রাখছি, pseudo force পরে, pseudo force একটু লম্বাটা হবে। বোঝা গেছে? ভালো করে পড়ে রাখ, থেকে রাখ, হ্যাঁ এখানে এখনো করে অঙ্ক ঢুকিনি,